Hello again. This is Mr. Ford, and today we're going to go through graphing with points that have this log or 1 over x values. So previously, we've actually gone through just plotting points, but specifically for some biology and chemistry. Now, those doing maths and physics will have to understand logarithms. But honestly, you will get these in biology and chemistry. And though it would be good to understand them and the reason why you have them, you honestly don't need to. So I'm going to show you how today you can just use your own skills and just using a calculator to be able to do this. Okay, so very quickly, a logarithm is very good because it's the way that it's built is that it turns a exponential graph or something like a growth graph into a linear graph. Okay, and like a 1 on x will turn reciprocal values into a linear graph. But luckily, your tests are going to tell you what you need to code them with, what you need to type into your calculator. So first off, let's look at what most of your calculators look like. So your first is, we've got your calculator here. So this is one of the normal calculators, but there's two buttons. The first one is this log button, okay? What it means is that actually means log base 10. You'll only ever be asked this. You won't be asked for other log bases generally. If you do, you have to use this special button and change the base, but don't worry about that. This is generally what you get, and I'll show you why in a second. Or you get this where it says ln. You don't need to know, but it's just known as a natural logarithm. So they're the same thing. This is just a different number at the bottom, but really you will just see these on your papers. Okay. But really the techniques and skills required are exactly the same as what you've done for normal plotting. So let's look at a question. So here is a question that we have. A series of experiments are carried out to investigate how the rate of reaction varies with temperature. What they get is they get these values here, and they get these values here. Okay, now this is a very specific type of calculation. I think this one's in chemistry, but it tells you in this column, it tells you this is 1 on t. So if you type into your calculator 1 divided by 286, you get this value. Now, if we do that exact same thing here, we fill this in. So 1 on 302 is going to be 3.3 times 10 to the negative 3. And over here, this one's slightly different, but see how it's got this ln? That's when we use this button. So we hit ln and we type this number in. Okay, and if you do that, you'll get that as negative 3.30. Okay, so now we have our values. Doesn't change what you're going to do. We've completed our table, but now we're just going to put this on a graph. So I'll show you why we need to do this on the next slide. So as we come down here, it says graph the values on the table on the previous page on the graph below. Now on the actual question, it will tell you that it wants the y-axis as natural log of 1 on t. So this is going to be the y-axis. So all that means is I take the values from this column. It tells you what to do. So we need to put the values in this. Now we don't know the values here. This one's been done for us, thankfully. We don't know values. As I said before, we have to actually have them in. So what we need to do is we need to turn around and we have a look. Now, what is the highest value? Because you notice our graph is actually decreasing. So our highest value is about negative 2. Our lowest value is negative 4. So that's what our range needs to be on our side. So if we come down here, we need this. Let's go out a bit. We need this to go from negative 2 to negative 4. So if I went down in a scale, remember the same rules as before. I want to use as much of this space as possible. So let's just make this one negative 2. Okay. Now, we want this to be up. We want this to come all the way up to negative 4. So we need about half of this to be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This isn't too bad. If it's 10 down, that means that 1, 2, 3, 4, 5, this should be negative 3.0, and this should be negative 4.0. Now, what does that mean each of these is? So, that means that since these are 5 big blocks, if I divide 1 by 5, that means each of these is 0.2. So this would be negative, no, not 0.2. Yeah, 0.2. This will be negative 2.2, 2.4, 2.6, 2.8, 3. You can fill these in, it will help you do the next section. And it would keep going down. Now, that means we've got these little boxes here as well. So same thing, that means I've got from 0, 0 to 20, and there's 5 boxes. That means if I do 20 divided by 5, that means each of these is 0.04. So this would be negative 2.04, 8, 12, 16, 20. Okay, just using the maximum scale that I can here, which is really important when I start putting values in. Don't forget you need to label this. This is natural log of 1 over time. Okay, let's go around plotting our points. So previously you would have, up here, I'm just going to use the values. Okay, so I'm going to use the values. So I'm going to plot this point against this point. So at 3.5, it is minus 9, 3.99. So here it is 0.99, which will be right there. 3.4 times 10 to the 3 was 3.3, which is going to be exactly halfway between 3.2 and 3.3. 3.3 is at negative 2.71. So this is negative 2, this is negative 2.72, so it's 2.71 is there. And 3.2 is at negative 2.08, which is right on that marker there, because it goes 2.04, 2.08. Last, I need to draw a line of best fit. This looks like a straight line, so I'm going to draw a straight line through it. Okay, so I've drawn a straight line using my insert line, and it goes mostly through these lines here because you can see it's a straight line, so I use a ruler for it. Just use your common sense for it. Okay. Now, that's it. That's a good 4 marks there, 4 or 5 marks there. Let's have a look at the next part. Now, this is actually a little bit interesting. So, this is just a nice little extension. But before I go into this, I want to make sure you've done this. And then you can even try the next one by yourself and then come back to the video. But if you feel confident enough, you can start right now. So, the next part here is we've got the equation for this experiment is given. There's a bunch of writing there required. But what we're going to do is we're going to go through this here. Sorry, that just had some issues. So what we've got here is if you look at this, our y-axis is ln 1 on t. Our x-axis is 1 on t. That's exactly what we had here. Our x-axis is 1 on t, and y-axis is ln 1 on small t, 1 on temperature versus 1 on time. Now, think if we look at this, then we look at this equation. That means that this is the y, and this is the x. Which, if I put that into this format, that means this here is the m, also known as the gradient. So the gradient equals this here. So let's have a look at how we can go about solving this. Okay, now this is a whole piece by itself, but it's all about activation energy, what the R value means, but it's just maths. That's why it's in this unit. So let's have a look. First off, if this is the gradient, that means we need to find the gradient. So let's turn around and let's go from this line, let's pick between these 2 points. This point and this point. Remember, gradient is how much it increases, the rate at how much it increases. So we need to find how much it increases in height compared to how much it goes across. So we need to find, so this is its change in y, and this is its change in x. So its change in x is its change from that to that, which is 0.1 times 10 to the negative 3. And its change in y is the change from here. So it starts at minus 2.04, and it gets to the middle value here, which is minus 2.7. So it's gone down. How much has it gone down? It's gone down. So I'm going to put it over here. Okay, so it's gone down 0.66. So and that's exactly it there. Because it's gone. That's, if you have a look, that's how much it's decreased by. So my gradient is equal to minus 0.66 divided by 0, the change in x. Okay, so if we type this into the calculator, we get a value of minus 6600. Okay, let's take that to our value. Let's take that down here. So our gradient is minus 6600. It also, if you notice, this is the gradient, which means that has to equal this. Equals minus e to the a divided by r, which gives us this value here. Just need to check that that's right. Yep. And this is all given to you by 8.31. The rest is a bit of maths. We're going to do algebra as another unit, but that cancels with that. So that means the EA is equal to okay, so we got 54,846. Okay, now the rest of it's a bit of science, bit of chemistry, but just by knowing some numeracy skills, you can answer a 6-mark question. Okay, just by knowing how to read a graph and use your calculator. Now, give a go at the next question, see how you go. Thank you for today.